Welcome back. Today we're going to learn a new property of exponents. We are going to learn three. We're going to work with powers of a power, power of a product, and power of a quotient. All right, so go to page 15 in your textbook. So today we're going to look at product of powers. So a power can also be raised to a power. So the exponential expression 4 squared to the third is a power to a power. It can be written as two repeated multiplication expressions using the definition of a power. So if we recall, if we had 8 squared, that means we want 8 times 8. But in this sense, we want 4 squared to the third power. So that's why it becomes 4 squared times 4 squared times 4 squared, which then is broken down. So 4 squared, we know it's 4 times 4. 4 squared is 4 times 4, and 4 squared is 4 times 4. So there are 6 factors of 4. So we're going to use that definition to write the repeated multiplication expressions for each power to a power. So in letter A, we want 8 squared to the third power. So like that first example, so we want 8 squared times 8 squared times 8 squared. So that would be 8 times 8 times 8 times 8 times 8 times 8. And there are 6 factors because 1, 2, 3, 4, 5, 6. 5 to the fourth to the second power, so that means we want 5 to the fourth times 5 to the fourth, which will be broken up, okay, 5 times 5 times 5 times 5. So that's for that first one. And then 5 times 5 times 5 times 5. And there are 1, 2, 3, 4, 5, 6, 7, 8 factors. Keep that in mind and take a very close look at those exponents. And I want you to see if you can kind of see a pattern going on here. And in letter C, notice where that negative is. It's outside the parentheses. So we want 6 to the first power to the negative 6. So I'm going to keep that negative on the outside. So we want 6 times 6 times 6, 2, 3, 4, 5, 6. So we want negative 6 squared to the second power. So negative 6 squared times, oops, let me put that, parenthesis there. I'm just going to rewrite it, sorry. So negative 6 squared, because we did learn how important that is, those parentheses when we have those negatives. So we want 6 squared times 6 squared. So that becomes negative 6 times negative 6 times negative 6 times negative 6. And there are 1, 2, 3, 4 factors. Now, if the directions did say to evaluate, we would actually give what does 8 to the 6th power, what does that equal? But for right now, we're just writing this out. And again, notice what I just said there. If we were to simplify this, this is going to become 8 to the 6th. For letter B, that is 5 to the 8th. For letter C, we've got that negative 6 to the 6th. And then for this one, we've got negative 6 to the 4th power. So let's take a look at question number 6. What relationship do you notice between the exponents in each expression and the number of factors? So for example, what do you notice with those exponents and the number of factors we had? Well, we had 6. Let's look at letter B. Let's look at those exponents, and the number of factors we had was 8. Letter C, those were our exponents, and the number of factors we had was 6. And for letter D, the number of factors we had was 4. Do you see the pattern? The number of factors is the product of the exponents in each expression. So for example, like how we said 8, ooh, I don't want the, I wanted to do, so 8 squared to the 3rd power is equivalent to 8 to the 6th. 5 to the 4th power squared is equivalent to 5 to the 8th. Negative 6 to the 1st to the 6th power is equivalent to negative 6 to the 6th. And negative 6 squared to the 2nd power is equivalent to negative 6 to the 4th. So for number 7, it says write a rule that you can use to raise a power to a power. Well, to raise a power to a power, you're going to keep the base. So for example, in letter A, we kept the same base of 8, and then we multiplied our exponents. 2 times 3 is 6. In letter B, we keep the base of 5, multiplied 4 times 2 to get 8. So right now, go to page 12 in your packet. So it's another practicing of a power of a power. So if raising a power to a power, you're going to multiply the exponents. And I'm also going to write it out just so you guys get into that habit of seeing what does that look like, how does that happen. So when we want x squared to the 8th power, we want x squared 8 times. Some of you saw that. Remember when I said that you could skip numbers 21 through 26 the other day? That's because those problems were just like this here. And I said we weren't going to get to that until today. 1, 2, 3, 4, 5. Whoops. 6, 7, 8. So that's x squared to the 1, 2, 3, 4, 5, 6, 7, 8th power. And if I were to even break this up further, so that would be x times x times x times x. I'm missing 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it'd be x to the 16th because 2 times 8 is 16. So now with the one that we have here, what I would do first is, again, we don't like the negative exponents. Now notice how there's a negative exponent here and on the y. First thing I'm going to do is I'm going to get rid of that negative 4 exponent. Remember how we do that is we flip it. So I'm going to take that entire thing and we're going to go 1. Oh, now, flipping at that time, all it did was it made that 4, that negative 4 positive. That y to the negative 3 didn't change, because what I'm going to do now is I'm going to flip it again to make that positive. So that would become y to the 3rd to the 4th, and then 3 times 4 is 12, so y to the 12th. So we ended up having to flip it twice there, and we're going to see a few more examples of that in the second section here. And the other reason is, if you look, well, what's negative 3 times negative 4? That gives you a positive 12. Okay, so the other one is a power of a product. So basically what that's saying is find the power of each factor in the parentheses and multiply. So when you've got a, b to the m power, both the A and the B are going to be raised to that power. So it's almost like you're taking that 3 out here, and you've got to raise everything to the third power. The biggest mistake is that we know the rule for our exponents is to multiply. That rule is not the same with that 4 out front. That's 4 to the third power, not 4 times 3. Be careful with that coefficient. So what I'm doing now is I'm rewriting this, and I'm raising each of those factors within the parentheses to that power. So 4 to the third, oops, oh no, there's my 3, is 64. 3 times 3 is 9, so I'd become x to the ninth, y to the third, and z to the third. Number 2, I don't like that negative exponent outside there, so I'm gonna go ahead and flip that entire piece of 7x y to the negative 2, and then I'll flip it again, okay? You could do y to the negative 2 first. If you look at the answer key, that is how I did it in the answer key. So I did it a little bit different. So I'll show you both ways. I'll do it differently in the next one. So I'm going to first do is move everything. I'm going to move everything into the denominator because what that does, whoops, and the whole point of that is that 2 of that exponent, that negative 2, is now going to become a positive 2. However, we still have that y to the negative 2, so he is now going to be moved to the numerator. And the 7x is going to stay down there because it's positive. There we go. So this kind of goes into the next one we're going to learn about is power of a quotient. So it's basically saying that same thing, is that everything, the y squared, the 7, and the x, each of them are going to be raised to that second power. So it'll become y squared to the second power. Oops, I'm sorry. Seven to the second power and the x to the second power. So that becomes y to the fourth over 49x squared. So what I'm going to do in this one, like I said, I'm going to do it the other way now, where I'm going to work inside the parentheses first. I'm going to get rid of those negative exponents on the inside first. So that was the notes that we had done on Friday. So seeing as that's the x and the y, both of those need to be moved to the denominator. The 6 is going to stay, and z to the 0 power is going to stay. So seeing as I move those two, they're now going to become positive. That did not change that negative 2 out here. So I will have to do it again. And now I'm going to flip everybody's position, because that will now make that negative 2, that'll make it a positive. And I didn't write z to the 0 because we learned on Friday that anything raised to the 0 power equals 1. So this is now going to become x to the 6th, y to the 7th, over 6, all raised to the second power. I'm going to go ahead and rewrite that so you guys can see that a little bit clearer. So give me 1 second here. Leave that parenthesis there. So I want to put x to the 6th, y to the 7th, all over 6. And so now that 2 has now become a positive 2. So going from there, I'm going to raise every factor to the second power. Six times 2, seeing as x to the 6th to the second power, we multiply our exponents to be x to the 12. Y to the 7 times 2 is 14. And then 6 squared is 36. I forgot I put those there too, so I didn't have to write so small. All right, so we also have power of a quotient. So we just kind of took a very brief look at that. So for any numbers a and b where b does not equal 0, if the quotient of a and b is raised to a power, you're going to raise both the numerator and the denominator to that given power. All right, so let's go ahead and start with that first one there. So basically the 2, we're going to raise the 3 to the second power and the 5. So this will become 3 squared over 5 squared. And if we were to simplify that, you get 9 over 25. Same thing, everything is going to be raised to the second power, including that 2. Okay, and again, you're not multiplying, it's 2 to the second power. So it'll be 2 to the second power, a to the 5th to the second power, b to the 7th to the second power. So 2 squared equals 4. A to the 5th to the second power, seeing as we're taking a power, raising it to a power, you're going to multiply your exponents. So it'd be a to the 10th, and then b to the 14th. First thing I want to do in this one is I do not like that -4 on my a, so we're going to rewrite that and move it to the denominator so that it will become a positive 4. So the 3 is going to stay in the numerator, a to the 4th is going to go down there, and then b to the 7th will stay there. And then we're raising everything to the third power. So that'll become 3 to the third power, a to the 4th to the third power, b to the 7th to the third power. 3 to the third power is 27. And then we have a to the 12th, b to the 21st. And 4 times 3 is 12. 7 times 3 is 21. Okay. Okay, so there's a lot of negative exponents here. First thing I'm going to do is I'm going to work with all of these here to make those positive. So it looks like everyone's going to switch their position. So we're going to have c to the 11th in the numerator, a squared, b to the 5th. That did not change. That did not change that -6 though. Okay, it's still raised to the -6 power. We have to flip it again to make that 6 positive. So we're going to flip. So it'll be a squared, b to the 5th, and c to the 11th. And then we're going to raise out each of those. So it'll be a squared to the 6th, b to the 5th to the 6th, over c to the 11th to the 6th power. So again, we're raising a power to a power. So that means that we multiply our exponents. So 2 times 6 is 12, so it'll be a to the 12th. B to the 5 times 6 is 30. And then c to the 66th. Okay, so for practice, you are going to do pages 13 and 14 in the packet. Page 13 is we're looking mostly at powers of products. And then 14 has a pretty much review of everything that we've done up until this point. Please do not hesitate if you have any questions. Again, the answer key is available online. Please make sure you're doing the work yourself and then just using that as a resource to check your answers. Okay? Thank you very much. Again, let me know if you need help.